All right, hi everybody. This section is 2.4. It's about finding equations of lines of best fit. So we are going to do this one entirely in Desmos. Okay, so what we're trying to do is we're trying to take data and we're trying to find the best line that we can that matches with that data. So I'm going to go over a couple of them with you from the Desmos assignment, and you should be able to take care of the rest. So question number one from My Open Math, if you were to open that assignment, you're going to see your question one looks similar to this. Maybe the same exact numbers, maybe not, who knows. Hopefully it's a different version. Okay, so first thing I'm going to do is I'm going to go and I'm going to plot these points. So I hit my point tool down here. I'm going to plot those points. So first quiz 19, second quiz 14. So you're just going to kind of eyeball it. My Open Math is going to be pretty understanding if you miss the point. So 23:17, we're just going to eyeball it and see, put a point right about there. 24:18 is going to be real close to that one, probably about right there. And then 43:36, so I'm all the way here at 43 all the way up to 36, somewhere like right around there. And then 44:40, be about right there. And then 48:41, about right there. 49:45 way up here, and then 50:47 on that line there. So there you go. There I have about what I want to do for that. Now it wants me to sketch a line of best fit. So this line, I'm going to hit the line tool right here, and then I'm going to go and I'm going to try to kind of draw a line up through there. As you can see, if you let it go, that's when the line's going to snap into place. You kind of want like half of the points being above the line, half the points being below the line. So let's see if that works, okay? See if that works. Submit question. It gave it to me. Very good. So, if you do this problem a few times and you're still not getting 100% credit, reach out to me and let me know. I'll take a look at it. I can override it. I mean, My Open Math may just have a thing against you or something on this one if you don't put the line exactly where they want you to. Okay, so just reach out if you don't get full credit and we'll try to figure it out. All right, let's take a look at number two. Number two, run a regression analysis on the following data set where y is the final grade in a math class and x is the average number of hours students spent working on math each week. Okay, so what we're going to do here is we're going to copy that table into Desmos. So don't select the x and the y, just copy the numbers. So just select all those, then copy, and then we're going to go over here to Desmos into the first line there and hit paste, and hopefully it works out for you. It actually puts an x1 and a y1 and it just copies the whole thing in. If it doesn't copy the whole thing in, well, then go down here and you're gonna want to insert a table. So let's see, you'd hit the plus button up here. Plus button. Why is it not allowing me to hit the plus button? Okay, well anyway, you're gonna have to hit oh, there it is, plus, and then you hit table, and then then you can edit manually. You can put it in there manually. Okay, so now they want a regression equation. So the regression equation on Desmos is really easy. You want to relate y1 and x1 with a line. Okay, see how it says x1 and y1 up here? So I want to do y1 equals mx1 plus b. But for Desmos to do that, you're just going to hit y1. You don't even have to worry about a subscript. And instead of equals, you're going to hit the tilde button. You'll see it left of the number 1 on your keyboard. You're going to see the little squiggly. I like to call it squiggly. So it's a tilde. So y1 squiggly mx1 plus b. And then it's going to give you a line of best fit. So it tells you my line of best fit has a slope of 3.05885 and a y-intercept of 41.2185. That's what I'm going to actually put in here now. I'm going to go y equals 3. I'm just going to put all the numbers. I don't know what my OpenMath's telling me for rounding, but that's mx. Make sure you put the x after the m, plus b is 41.2185. You could hit enter, make sure it takes, and there you go. Then it asks you the question, what is the predicted value for the final grade when a student spends an average of 12 hours each week on math? So you want to actually go down here now into Desmos, and you want to type 3.05885 times 12 plus 41.2185. And then there you have it. Then it gives you the score. So that is the predicted score if you study 12 hours a week. So 77.9. Alrighty. So that would be how to use your line of best fit to predict what your score would be if you work 12 hours a week. You notice it's not 80.8. Don't just read it off the table. Use your equation and plug the number in. Okay? Let's see. We should do one more because your number 5 asks you for what's called the correlation coefficient. Okay, the correlation coefficient measures how close you are to being an actual line. So if you're closer to 1 or -1, you're closer to being a line. So if you got a correlation coefficient of like 0.996, that's pretty good. You're probably, that's a perfect representation of that data would be that line. If you had a negative 0.996, same thing, it just has a negative slope. Alrighty. A correlation coefficient of like 0.1 is terrible. You would probably choose a different kind of regression, like exponential or logarithmic, something like that. It would not be a line in that case. Alrighty. So I need to do my regression analysis on that set of data. So I'm going to clear everything out. Now I'm going to copy and paste that in. Don't copy and paste the XY. Just copy and paste the data. So copy, paste the data. And then I go down there and I'm going to go y1 squiggly mx1 plus b. And I get my m and my b. You could see that this time you got a negative slope. That's why your r value, which is the correlation coefficient, r is the correlation coefficient, negative 0.97 is pretty strong. That indicates that's pretty close to a line. All right. So here we go. I'm going to enter that value in, negative 0.9773. Submit question, and there you have it. Okay, so that is 2.4, y'all. That should be a pretty quick assignment. Enjoy that, and we'll see you in chapter 3.